All right, this is our geometry. Let's see, geometry review. Should be 1 through 40. I'm doing this for you guys after school, so I don't have anybody in the room. So we're going to look at this kind of question by question. This test does have 20 questions. First question up is going to be dealing with medians, or sorry, mid-segments of a triangle. Okay, they're going to tell you that these are medians. Let's see, let's go ahead and label this A, B, C. Okay, we'll get a median here. We'll get another median here. And we'll get another median here. Okay, now you're told that these are medians. Let's go ahead and label some other points here. Let's call this X. Let's call this Y. We'll call this Z. And we'll call this point here in the middle, we'll call that P, point P. All right. Let's see, so looking at this, they're going to say, let's say something along the lines of CX. Let's say CX, that's that whole red median line. CX is, let's say, I don't know, let's say 18.5. 18.5 is CX. They can tell you that, oh, let's say this distance BP. They might say something along the lines of whatever BP might be. They're going to tell you that all of these lines are medians, but what we want you to find is, let's see, they've told you what CX is, but they want you to find just CP. What is CP? All right, so what you want to notice is that CP is the distance, the vertex to the centroid of that median. So vertex to centroid, vertex to centroid equals 2/3 of the median. Okay, it's 2/3 of the whole length. So if I know the whole length is 18.5, the measurement, let's see, if we're trying to find vertex to centroid, we're getting, you know, CP, we'll call it X here, is 2/3 of 18.5. Okay, well, in math, of is multiply, so we're going to take 18.5 times 2 divided by 3. And in our case, we would get X equals 12 1/3, or 12.3 repeating. Okay. All right, I just want to double check. Make sure I don't give you any wrong information. Yep, that's exactly what we want to do. Okay. So that's the way we would set this up. It's a very similar question, but it's going to obviously be different numbers. Number two is going to give you a triangle on a coordinate plane. Something that'll look a little like this. And it's going to ask for the coordinates of the vertex. And this is where I'm going to deviate from what I've done in the past. All right, for instance, like let's say that this is -3, 0. Let's say that this is 4, 2 right there, and we'll say that this is 3, 3, 5. Okay. In the past, what I would have had you done is use your midpoint formula to find this point, and this point, and then draw your lines back to here, over to here, and right to there until we had this green point, and that would have been your centroid. But for sake of your test tomorrow, what you've learned, and what you guys actually showed me, honestly, is that you can add up all three of your coordinates and then divide by 3. So you could take -3 plus 3 plus 4. Of course, you wind up with 4 divided by 3, and that'll give you your x coordinate. So, you'd wind up with 4 divided by 3. You'd get, in this case, like 1.3 repeating, or 1 1/3. Okay? And then you would take your y. So you'd take your 0 plus your 5 plus your 7, divide by 3. 5 plus 7 is 12. 12 divided by 3 is 4. Okay, you get 4 for your y. So your whole coordinate is 1 1/3, 4. Okay, and I'm going to hit pause for a second just because I want to double check on that information. Yeah, and just double checking to make sure that that works and it works on your test. That absolutely will work. So add up your 3 x coordinates, divide by 3, add up your 3 y coordinates, divide by 3, and that's going to give you the coordinates of your centroid. So if you can show me that work, you're good to go. All right, number 3. Number 3, let's take a look. All right, they're going to give you some links, let's say 10, 14, and 20. They're going to say, does this form a right triangle? And the question is a simple yes or no answer, but in order to get credit, you're going to have to show some work. All right, so the rule to this, does it form a right triangle, is you have to set up according to the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. And the most important piece in that is the c squared, because the c squared, given this, is the longest side. So that's going to be my 20 squared. Okay? Doesn't matter on the other two. That's going to be 10 squared plus 14 squared. I know 20 squared is 400. We know 10 squared is 100, right? And 14 squared is 196. All right, so that's only giving me 296. That does not equal 400. So my answer there would be no. No, it doesn't. But I've shown my work to be able to earn that answer. Okay? So don't think just because it's simple yes or no that you're automatically going to get credit. Okay, you do have to show some work there. All right. Then they're going to give you some other links. Let's say, 6, 17, and let's try 24. Okay. They want to know what kind of triangle this comes out to be. Same principle here. 6 squared plus 17 squared. We're going to leave a little blank spot there for 24 squared and actually see what the relationship is. Well, 6 squared is 36. Okay, 17 squared is 289, and 24 squared is 576. Okay, well, 36 plus 289 is 325. 325 is less than 576, and because the hypotenuse side is big, it is obtuse, because it's forcing those two ends apart. Okay, it's making that angle big, therefore it's making it obtuse. Okay, if for some reason it had been less than, right, it would be acute. Okay, if it had been equal to, it would be right, but in our case it's obtuse. All right, but I'm going to show my work to earn my answer there. Okay, let's move on to question 5. Okay, they're going to talk about a community building that has sides that measure 210 meters. Okay, 210 meters. Okay, let's see if they say it's a square. And it is a square. It is a square. They tell me it's 210 meters. So it's 210 meters. all the way around. And then they tell me, because this it's a park, I guess, to separate the two areas of this park, they have a diagonal line that cuts through it. Now, because this is a square, I know that it has right angles, okay? But I've got a diagonal line that separates the two areas of my park here, okay? We want to determine the approximate length of that diagonal line. Now, if I see this, I should see that I have a right triangle. If I want to try to find this length, which is my diagonal line, I can simply do the Pythagorean theorem. 210 squared, 210 squared equals c squared. 210 squared is 44,100 plus 44,100 equals c squared. We'll add those up. Okay, we get 88,200. We square root both sides. Okay, square root. I have 88,200. Okay, c gives me something along the lines of, and they want us to round our answer to the nearest tenth. All right, so the nearest tenth is actually going to give us 297.0. It's actually 296.98, but if I'm going to round, I would have to round that 9 up to a 10. It's going to round that 6 up to a 7, but I have to leave something in that tenths place. So 297.0 meters on a question like that. 6. Okay. 6 is a proof. Okay. And like a lot of these, I'm not going to necessarily go through it. It's proof of a parallelogram. So you want to go back and look into your parallelogram questions. Give me a second here and I'll tell you what lesson to look up. All right. So for this, what you want to look up, if I can find my marker, look up lesson 34. Okay. You should find a question in that video that's going to match. So you want to find a proof question in that video. Okay. We'll move on to number 7 from here. Number 7. Number 7 is area of a sector. They'll give you something that'll look somewhat like this. Okay, this is going to be the center of the circle here. We'll say that this is 6 meters. And let's call this P, call this N. So we're looking at this distance right here. And let's say it's 46 degrees. Okay, 46 degrees. The area of a sector is based upon the area of a circle. So we would use pi r squared. It's my area of my circle formula. But we don't want the whole thing. We just want a fraction of it. So we're going to use the degrees that we have over 360 to find out what that fraction is. So in our case, we're using pi 6 squared 46 over 360. And we want our answer in terms of pi. So we're going to look at 46 over 360 times 36, or 36 times 46 divided by 360. That actually gives me 4.6 pi, and this would be in centimeters squared in this question. Okay, again, different number, same question. Okay, but that's good practice for you. Okay, number 8. Number 8 is another proof style question, and I'll just tell you where to look that up. That question has been done. I'm not going to do it again here today. What you want to do for question number 8 is you want to look up lesson 36. Okay, so on 8, lesson 36 video, proof question. Okay, and you'll see it'll look something like this. Okay, so you want to look up a proof question. It's going to look somewhat like that. Okay, and see how to solve that. I think it'll throw in a little bit of extra information there. All right, let's move on to question number 9. Okay, question number 9 is going to show you 2 triangles. Okay, let's see, let's do something like this, and let's say A, B, C, D, E, F. It's going to ask what is the congruent statement and what supports it. Notice that these are 2 right triangles, so I'm going to start off with triangle ABC. Okay, it's going to be congruent to triangle, and I'm looking at what corresponds to A. Of course, A is a right angle, so D is also a right angle. All right, B is on that same, shares a side with A that has 1 tick mark. So D shares one side, or E shares one side with D, but has 1 tick mark. So it's a E, and then all that's left is that. Okay, they could be out of order a little bit. The next thing I want to notice is because these are right triangles, this is actually using leg. Okay, now I'm not using any hypotenuse or any acute angles, so I'm using leg there. They could be other options that could show up on the test are things like hypotenuse leg. We've got leg here, hypotenuse angle. What else do we have? We've got leg angle. Okay, those would be other available options depending upon what the picture looks like. In this case, it's leg. Okay. Number 10. Number 10 is going to give you four lines. And it's going to ask you which lines their equations are 4 lines are given. We want to identify parallel lines. So you might see something like y equals negative 16x plus 10. Okay, let's see what the next one. Next one may have something like could be x plus 1/4 y equals negative 16. The next one could be y equals, let's say negative 6x plus 12. The last one might say y minus 4 equals negative 1/16 x minus 16. Okay, your job is to get them all into slope-intercept form and check the slopes. All right, look and see what slopes are the same because we're looking for parallel lines. So it could be lines 1 and 2, could be all 4, could be 1 and 4, could be 2 and 3. You've got to go through and check. Okay, convert to slope-intercept form. So you're trying to get everything into this, and then you're checking all of those positions, the ones that are the same, those are lines that are parallel. Okay? All right. Might get something like this, where I know that these two angles are the same. Let's label this out here. Let's call this A, B, C. Let's call this 30. Let's call this x plus 10. Let's call it 2x plus 10. Let's call this 6x minus 6. And let's call this 36. Okay. The question is going to ask what is BD? What is that length right there? Okay, and that's the important part, because it's going to mean that I'm going to solve for x, but I need to plug x back in to find out what BD actually is. So in this case, what I'm going to do is I'm going to write 30 over 2x plus 10 equals 36 over 6x minus 6. That's over that. Okay. So we'll cross multiply. Okay. That's going to give me what? 72x plus 360. Same thing here, cross multiply. Okay. Let's see. 30 times 6. I believe that's 180. 180 x. 30 times negative 6 be negative 180. Okay, we want to solve for x. So let's see. Let's subtract 72x. And let's add 180 to both sides there. Okay. 360 plus 180 gives me 540. And 180 minus 72 is 108x. Okay, 540 divided by 108. Okay, I get x equals 5, but I'm not done. I have to plug it back in. So 6 times 5 minus 6. So I'm getting 30 minus 6. So I get 24. BD equals 24. Okay? So that worked right there. 12. Let's see. We are given a triangle. Let's see. H, I, and J. We'll get something like 31 and 52. And the question is that it wants us to list the sides from shortest to longest. Well, the first thing I have to do is figure out what is angle J. Okay, so we're going to take 31 plus 52. That's 83, so 180 minus 83. Okay, is 97. Okay, so this is 97 degrees here. And they wanted shortest to longest. So I'm going to look at this from the smallest side. So 31 is my smallest angle. So IJ is my shortest side. Okay. My next longest or next largest angle is 52. So I'm going to go across to it. It appears to be HJ. Okay. And then my longest angle is here, come across over to here, that is HI. Okay, from shortest to longest, it is IJ, HJ, and HI. Now, it's going to be kind of written out, but this could have been JI, JH, and IH. It wouldn't have changed anything. Those are still the same sides. All right. Number 13. 13, they give you three sides and they ask, can this form a triangle? Let's try something like 6, 2, and 6. Cannot form a triangle. So we're going to take 6 plus 2. Is that greater than 6? Well, yes, 8 is greater than 6, so that'll work. Okay? Is 6 plus 6 greater than 2? Yes. Okay, so we get yes. We got 12 is greater than 2, so yes. Okay. And then we would have the other 6 and the other 2. So 6 plus 2, is that greater than 6? 8 is greater than 6. Yes. So my answer is yes, that can form a triangle. And the reason is because any two sides of a triangle, any two sides of a triangle have to add to be more than the third side. So that's why we did it the way we did it. Okay, 14. The diagram. You're going to get a diagram. Let's take a look at it here. Let's see. Let's say A, B, C. We've got, let's say, 400 miles and 480 miles. Okay. The diagram shows the approximate distances from Houston. Let's see. Okay, we got to kind of change this a little bit. We got Austin. We need D and H, so I need to change this a little bit. D and H. Okay, so these are the approximate distances from Houston to Dallas and from Austin to Dallas. What is the range of distances D from Austin to Houston? So we want to know what is the range of possibilities for this distance right here, and it uses the same principle that we just looked at. Any two sides of a triangle have to add up to be greater than the third. So we know that 480 plus 400 has to be greater than AH. Okay, well that's going to be what, 880 has to be greater than AH. Okay, but also AH plus, let's say 400 has to be greater than 480. So we would take 480, okay, and subtract 400, okay, to find out what that's going to be. Okay, 480 minus 400 has got to be 80. So that's got to be, AH has to be greater than, or sorry, AH has to be greater than that. So what we get for our range of values is AH here in the middle. AH has got to be less than 80, and it's got to be greater than 80. And if we look, like let's say I plugged in 80 here. Well, 80 plus 400 is not greater than 480. They have to be at least 81, right? And if it was greater than 880, right, let's say it was 881, right, then 400 plus 480 isn't greater than it. So it's got to be between there. So it's got to be, less than 880, okay, and greater than 80. So this is my answer right here. Okay, range of values. Okay, 15. A lot of triangle inequality stuff in here. 15. The length of two sides of a triangle are 6 and 16 inches. We want to find the range of possible lengths of the third side. So that's the exact same thing. Okay, we're going to take 6 plus 16, okay, which should give me, what, 22? And 16 minus 6, okay, which is 10. So x has to be less than 22. It's got to be greater than 10. Okay, it won't be a negative number, right? You can't get a negative number for a length of the side of a triangle. Okay, so if it helps, take largest side plus smallest, take largest side minus smallest, and our number will be between those two things. Okay? All right, 16. Says find the area of a composite figure, and they give you something that's going to look similar to this. Okay, where we're going to say this is 24 feet. They'll tell you that this is 18 feet. Let's see, they'll tell you that this is 18 feet and that this length across here is 36 feet. All right, so you can start off by finding the area of your big rectangle in here, 24 by 36. Okay, that gives you 864. And then find the area of your two triangles. So base times height, or 18 times 36 divided by 2. 18 times 36 divided by 2. Okay, so that's 324 for 1. Notice that's the exact same thing for up here. So I should get another 324. I can add up all those things together. 324 plus 324 plus 864 should give me 1,512 units squared. I think in this case it's feet. So yeah, feet. So, okay, 1,512 feet. So really not too hard. Add up your areas of your composite figure and you should be fine. All right, next one. Okay, they're going to tell you in a parallelogram, let's say parallelogram A, B, C, D. Let's say angle B equals 55 degrees. Okay. All right. Let's see. We want to know what is angle C. Okay, well, we start off by drawing a parallelogram. Something like this where it's not just guaranteed that it's all right angles or something like that. So we'll start off here, A, B, C, and D. And this doesn't have to be visually correct. Okay, but we're saying this is 55 degrees. Okay, we want to see angle C. All right, so this is where I lean on consecutive angles of parallelograms are supplementary. So 55 plus angle C equals 180. They're supplementary. So I'm going to subtract 55 from 180. Angle C, okay, 180 minus 55 should give me 125 degrees. Now, if they were looking for angle D, it would be 55 degrees because opposite angles of parallelograms are congruent, so I wouldn't have to worry about it. But consecutive angles are supplementary. Okay, I have to know that, though, in order to even begin to do the math. 18. Okay. You got two triangles. One of them is going to be kind of positioned like this. The other one kind of positioned like this. They look pretty similar. Say L, M, N, and let's see. Let's call this A, B, C. Okay. They're going to tell us that, let's see, they're going to say that CB is congruent. Let's say CB is congruent to MN, okay? Or in M. CB is congruent to NM. We want to know, and they say that angle, let's say the angle C is congruent to angle N, okay? If we know that angle A is 42 degrees, what is angle L? And the answer is angle L equals 42 degrees because these two right triangles are congruent using leg angle congruency. Okay, we have a leg and we have an angle. We've got a leg and we've got an acute angle that correspond to each other. These are right triangles, so I can use my right triangle congruency. Therefore, their corresponding parts are congruent. And angle L corresponds to angle A. If angle A is 42, then angle L is 42. Okay. All right. Let's see, 19. 19 is going to give you a line, something like y equals 4x minus 14. And then they're going to give you four different lines. They want to know which one of them is parallel. So you might see something like y equals x minus 14. Y equals, let's say, 6y minus 12x equals 0. Okay, there's another one. Y equals negative 1x. And let's say y equals, let's try, how about negative 8y equals 4x, or none correct. Okay, with this, you've got to convert all these to slope-intercept form. This one here is already slope-intercept form, and because it is not 2x in terms of its slope, all right, it's not going to be that. All right, so the next thing that we would do here is divide by 6. All right, this would give me y equals negative 2x. Actually, though, hold on a second. I would have to add 12x to the other side. So in the process, I'd get 6y equals 12x plus 0. Divide by 6. I get y equals 2x plus 0. Notice that this has the same, actually no, it doesn't have the same slope, so it's also out. Okay, we would say that this doesn't work either. All right, this one doesn't have the same slope. Over here, I could divide by negative 8. Okay, that's going to give me y equals negative 1/2 x. That doesn't have the same slope. In this case, none of them are correct. Okay, but you know what you need to be aware of is that there might very well be an answer in your test. There just wasn't one in this one that I made up. All right, finally, number 20. Number 20. Number 20 is another proof question, so you got about 3 of them. Okay, it's going to come from lesson 37. So you're going to want to look in the video for lesson 37 and find a proof question that we've worked out. Should probably be in there. Let me take a look at that question real quick again. Yep, that's one that we've seen. In fact, you've seen this one on a test before, so you should be well equipped to do that. So we'll stop right there. If you guys have questions, let me know, email me. I'll try to send this out to you as soon as I can.